Hello.
Why, hello.
Hey, you doing good?
I am doing very well. How are you today?
Great. Lovely weather. Had a good
Excellent.
lunch.
Excellent.
Just perfect.
Lunch is the most important
But
meal of the day.
this is what they say. Where are you based? I guess you just had your breakfast.
I did. I'm in Columbus, Ohio, in the States, Eastern time zone.
Hmm. All right. But I know we have this saying that I'm not sure this is the same in other languages. Eat like a king. I think at in the morning, eat like I think kind of a duke or something at lunch, and
Okay.
then eat like a beggar in the evening. Kind of giving most importance
Okay.
in contrast to what you said to the breakfast effect.
Well, back when I worked in an office, the team I worked with, we would all go out together for lunch. So it was an important bonding experience. I don't have that anymore working at home. Yeah.
Yes, same here. I'm missing this a little bit, I must say. So I was chatting with Jonathan earlier on. So he's off on vacation apparently. I'm not sure whether Abdullah will be able to join. Let's see, and
Hope
we'll
so.
just
He's
wait
the
for
one that
people
wanted this
hopefully
time.
popping up. Sorry?
He's the one that asked for this time.
So he should be. So how many OpenSSF meetings do you attend per day? Just asking out of curiosity. Kind of like feels like
Today,
5 to 8.
um, today just two.
Oh, that's
Yesterday I had
manageable.
two. Tomorrow I have three. Thursday I have four.
All right. So I think I didn't look up your profile. So for which company do you work?
I
Or are
work
you
for Intel.
independent? All right.
So my day job is boring, talking about computer chips. My fun jobs, I get to work with open source.
Oh, talking about computer chips doesn't sound so boring, I find.
It can get kind of dry.
Well, maybe, yeah, I don't know. I guess depending on which parts you work on. I think especially in the US, there were very heated discussions about computer chips, where they are produced,
Yep.
uh,
Indeed.
what kind of what diligence they need to go through when you import them,
Mhm.
and so that sounds pretty exciting to me.
Yeah, it I work a little bit with the public policy folks, so that's kind of interesting, talking to different governments around the world. I also get to do that here. It's more fun with the open source people because they're
Mm.
just happier people. Uh, yeah, I'm
Yeah,
talking
then,
with
then the government people. Yeah, I can understand this.
yeah. Actually, I have a meeting today about the CRA. We're talking about the EU CRA,
Yeah. Okay. So there's this
cyber
European
security.
legislation going
Yeah,
on. I read there were OpenSSF was basically complaining about their first draft, and then I saw some emails going around, or maybe Slack challenge, where there was an open letter or a response formulated by the OpenSSF.
yeah. We did a response. I think the idea behind the legislation we feel has a lot of merit. It's very good. It's well intended, but some of the language is pretty aggressive towards open source maintainers, which we're a little disappointed in. We'd like to have that adjusted. But overall, the idea is good. Everybody should have the ability to hold their suppliers accountable. We feel that's a good thing. It's just with the open source, it's a little strange since no one. It's not necessarily somebody's job.
All right. Yeah, I guess they're just the people writing this up are maybe not so very familiar with this whole open source ecosystem. So this is maybe explaining the language.
It's weird because I work
Sorry.
with a lot of folks in the UK and Ireland, And those entities have a pretty good understanding. There's a pretty robust partnership between government and open source, where the government heavily leverages open source, especially I was talking to some folks in Ireland, some public utilities folks, and they have a lot of very close relationship. So I don't know where this particular legislation came out of, but yeah, we're working to see if we can get things adjusted and make it a little better for open source.
Bit by bit, step by step. I see.
Exactly. Every day a little better.
I got just a ping by Abdullah. It looks like, I'm just reading out what he wrote me. There's a slight chance of conflict today since I just got back from a short break. Ping you in about 30 minutes to confirm. To confirm that there are conflicts, or to confirm that he's available. We will see. So it looks like it's just the two of us for today. So maybe we just sort up and prepare a little bit the ground for the activities to come. Yes, I have here again in the chat the link to that architecture.
Thank you.
And what we should also do is we should have kind of, I think the best would be to have kind of a template for a threat modeling workshop or so, in order to document the kind of the findings and the assumptions and the scope and the threats in a kind of known way. Let me just quickly look this up. See whether I have something here. So this is the thing that you have looked at already a couple of times, I suppose. I hope.
I've only seen this one once. I had asked Jonathan, and he had forgotten to send me the link because we flashed it up in the end user group once, and I really thought it was pretty well done.
Then maybe let me walk you. So what we will be looking at is slide number 4, right?
Yep.
Because we are still missing a little bit of input from a smaller development organization on how kind of a generic architecture can look like for small organizations. And so with John and Abdullah, especially with John, we felt more comfortable, and also me formerly working for SAP, we felt more comfortable writing the one up for the large scale in-house development.
Yeah.
And so just to walk you quickly again through this diagram, basically you see on the very left-hand side kind of the developer, right? Working on his workstation, developing code locally, pushing.
And is that an employee or an open source developer?
No, these are employees, because the whole idea is to take the perspective of a open source consuming organization, a big enterprise in this example. And maybe let me just share maybe I can share my screen, or do you think?
If you want to, you can. I have it right here. I have a giant, so it's. Oh
no, but I mean, then we keep it like this. Okay, so you have basically on the left-hand side, right? You have the developer of such a large-scale development organization, sitting at his workstation, developing and pushing code to a source code management system. From there, it is brought to some in-house build systems based on Jenkins or Tecton or maybe some other build systems, God knows.
Sure.
And then,
yeah, there'll be a lot of variety there. I agree.
Exactly. And this will be also I guess this will be also a challenge in the threat modeling, that we kind of need to abstract a little bit from all the different specific technologies in place on all those systems. Yeah. And so I think in this sense, I guess the threat modeling is a little bit more high level, as if you would do it for a specific application where you know very well kind of all the entry points and all the data flows. Yeah. So this generalization, I think, will become tricky at some point in time. Anyhow, then basically the blue arrows indicate the flow of proprietary code, right? From the source code management to the build system to the private internal binary repository such as Nexus or JFrog. And from there, it will be uploaded to some distribution platform. Could be some marketplace, a website of that organization, but sometimes even commercial organizations, they of course also release open source components. So in that case, they would end up on PyPI or maybe other package repositories or package registries. So the blue one is for the proprietary code.
Would you also consider that distribution platform something like a portal or like an online banking website? Would you consider that also, or you're strictly like an app?
No, this is basically the lower part, I would say, where rather than just making a downloadable artifact available to users, as I described before, in this case, you would basically operate, the organization is operating the solution itself. So it goes through this QA staging process and then ends up in production. And so that would be this portal page that the user opens in his browser. So this is the lower part, right?
Okay.
These are the two,
get it.
Right. So these are the two different kind of, the lower part is kind of the cloud service.
I'm kind of trying to just a watcher here. So are you sharing any screen?
We were talking through the document that I shared in the chat.
There's a link in the chat.
Oh, okay. I changed the device, so I guess don't have that.
No worries. It's just a little easier. We can make it bigger and then actually see each other's faces. But if you'd like to share, we certainly could. I re-put the link in there, Victor. And Heinrich is just kind of describing the document for me. It's been a little bit since I've seen it.
All right, thanks.
Okay. And I'm just sharing my screen now.
Cool.
You should be able to see something. Do you?
Yes.
Perfect. All right. So basically the lower part is where the proprietary or this software development organization is operating this solution, kind of cloud service solution, while the upper part is more for on-premise software that has to be made available, and that is downloaded and deployed locally by users on-premise. Right, that is the blue arrows, and then at the top we basically have in red and is the open source code or third-party code that is basically coming from the internet and which is downloaded and which runs on all those different systems, right? Mm-hmm. Both on the build system, on the source code management. Well, actually, source code management maybe not so much. Maybe here kind of. But then definitely on the workstation, on the build system, and also third-party open source dependencies, libraries are downloaded and basically mirrored on the Nexus and other private binary repositories. So this is kind of the flow of open source and third-party code, right? And then basically. This is any question, but maybe on the top right, these are so kind of the stakeholders or personas interacting with those systems are the developer on the very left-hand side, the user on the very right-hand side, which is somehow downloading or consuming the application developer, that organization. You also have inner source contributors that follow this open source approach, but from within
they're on the project
the company. And I'm not sure whether this is, at least at SAP, when I worked there, this was quite a thing and it was heavily promoted. I'm not sure whether this is by now considered commonly adopted or not, but we found it worthwhile to also highlight this in particular, because we thought in the beginning we could also cover insider threats, but we were saying maybe let's keep them out for the time being, start with a reduced scope, because anyhow it's relatively big supposedly, and we can add this at a later point in time. So these are the three stakeholders we were able to basically connect and relate to the different systems of that architecture, of this high-level architecture. The other kind of roles or personas that relate are the ones on the top right, people working on vulnerability management, reliability engineers, all the system and service administrators that configure build services, source code management system, private repositories, and many other pieces that are also connected here. But we didn't feel it is right to really connect them to all those systems, because we would have so many edges in this diagram. This would just explode everything. And then kind of the same holds true for the other homemade or third-party solutions that also run in-house in such organizations that are used maybe to store credentials, the configuration management database, a solution, all those static and dynamic application security tools that would be invoked during the build system or by the build system. And so we felt maybe do not connect everything in order to keep that image manageable and consumable.
So I would suggest we document the assumptions so that new viewers can see that. I agree with that choice, because the diagram would get super busy. And then I have two questions for you.
Yeah, let me just write down those. I'm just writing on another screen. I guess you don't see that window, but it doesn't matter. I will share this document. Yeah, I should share this probably right now, that you can also edit this. Let me just do this. So assumptions were basically some roles or actors and internal systems are not linked to Go ahead, shoot your question.
First question, since you noted the developers workstation, and we're going to threat model this, do you think there's value in adding some type of system or device for the end user, since that'll also be part of the attack surface? Or do we don't exclude that as an assumption? We're not going to talk about the end user.
We started dedicated slides for the user. I would not want to model also the user's workstation, because for me, the whole idea is basically supporting development organizations to not be compromised by malicious third-party code consumed throughout the whole development process. So the goal basically would be that whatever is downloaded or consumed by the user is, let's say, untempered, secure, and then whether it gets messed up at the user's workstation is of course also a problem, but one outside of the scope of the diagram of the exercise. So
we should document that as an assumption then.
Yeah.
And then that would also exclude things like an enterprise LDAP, source of identity. If an attacker gets in and compromises that, then has access to all the endpoints the developer can get to. So yeah, that would exclude a whole set of other things, and we should note that that's not part of this.
Yeah. So this is basically on the scope, right? So
yeah.
The goal is to kind of
we're looking at that third-party component, how the third-party components impact the internal development.
Yeah, is on the consumption of third-party open source components that threaten basically the security of the applications developed by this organization across the development lifecycle.
Mm-hmm. And then my last question is: we have the taxonomy that Pierre Giorgio and others are kind of caretaking. Is the intention for the threat model to apply that? Or, these are the attacks?
Exactly, that is the idea. So basically, this taxonomy that Pierre Giorgio and I developed.
Oh, both of you, okay, awesome. I love that, by the way. Very well done.
Happy to hear this. So yeah, the idea is basically to use this as an input to this whole threat modeling exercise, right? And so basically, the taxonomy is showing all the different ways for attackers to compromise open source components that are then consumed by such development organizations, right?
Thank you for answering my questions.
You're very welcome, of course. Development life cycle. Then Victor, do you have any question?
No, it was, yeah, I knows, I love the diagrams. This is also a good diagram. It just give a newcomer to the, I'm a database guy. By the way, I love chips too, but security is very interesting. And but without a deep knowledge, the diagram is a great way for me to understand the landscape. So yeah, this is good.
Great, hope you like it. Good.
One thing I would say that I just looking at the one area that I just joined different kinds of community meetings. I know for like financial industry, banking especially. So the inner source is big because it cannot share a lot of the technology outside the firewall because of legal, as well as not understanding the details here. So yeah, this might also help the companies that sort of want to contribute to the open source to understand where, when it comes to security, where to join the line and how to make it happen.
Right, I'm not sure whether we have the same understanding of inner source here. So in my mind, this is if you have big corporations with, I don't know, hundreds of development teams that consume each other's artifacts and components, that you have, I don't know, a development team working on the other side of the globe could still propose and make contributions to the components done by a different development team of the same organization. So the idea being applying open source principles to internal development teams. So I'm not sure whether we share the same.
That's right. So what I mean is, for those companies, there's no, I think you mentioned earlier, contributing to open source. For those companies, they probably hard for, like for example, a developer from a bank to contribute to open source. There's a lot of obstacles. Yeah, this could be help understand the security aspect of it.
Okay, but then the difference is, or the kind of the two kinds of contribution is internal teams contributing to open source and publishing something at open source, or internal teams contributing to other internal components. I think that is the, but yeah. All right.
And we probably also want to potentially document that in the scope, that we're not currently focused on the enterprise contribution back to open source at this point. That could be a future thing if we're interested.
Okay, let me do something. Let me share the document so that we can basically jointly document things, because otherwise I will be the bottleneck for writing things down.
Oh dear. Right? Don't want that.
Huh?
Don't want that. Don't want to be the bottleneck. Don't want to put too much pressure on you.
No, I don't want to be a bottleneck. Right. copy links. Anyone with a link? Copy link done. Sorry for. Now I just need to find the chat. All right, so here I need to. I will look up your proper name at some point. I will work on and polish this whole document a little bit later on.
I think for now it's fine that it's just some loose notes. You know, we're just at the very beginning of this process, and when we're done, we'll have something more formal.
All right. Scope. So inner source contributions are out of scope in the beginning. Right. We also already had, and just feel free to jump in and add to what I wrote down here, right? We also did with in a previous meeting with John and Abdullah, we came up with a couple of assets to protect, right? And the ones that we basically decided on is basically the kind of the source and the binary code of the development organization. And let me put in proprietary source and binary code of the development organization. We also had the kind of all those credentials and secrets of basically developers or stakeholders or of personas involved in the development process. So this holds true in particular for, or not in particular for example, for the stuff in the workstation, right? All those API tokens, God knows what you have there, and which is often exfiltrated by malicious software. We also thought to basically have the systems as such as an asset, because we do not want to have any of those systems mining cryptocurrencies for providers or attackers, let's say, on any of those machines. And I think there were some cases indeed where I think it was it Tesla, so 3 or 4 years they had vulnerable Jenkins running on AWS, and then somebody exploited a vulnerability in Jenkins and had a lot of cryptocurrency mined.
So do you want to say that there's some degree of security assurance of the infrastructure? Like you're not worried about co-locating trusted and untrusted workloads and someone running a side channel attack to siphon off data. That's not part of our problem space. Or do we, like the Tesla example, do we care that somebody's running out in the cloud?
I think to some extent, since we chose to use this in-house build system, we kind of got around this problem, right? So there will be also shared workloads, kind of build jobs running in parallel on a shared machine. But since we excluded insider threats, I would, pause this for the moment and include this at a later point in time. If it ran on AWS, then that would be in scope right away.
So do we agree that the assumption is that all the infrastructure is inside the wall, so to speak? It's all inside some type of protected data center, or will there be potentially elements that do run on public resources?
I mean, it's for us to decide, right?
I would suggest we start with with it's all internal, and then maybe shift to maybe the build system or the source code repository is external. But I think we should start off as simple as possible to test the process.
Yeah, all right. So initial assumption, let's call this initial assumptions. All systems run
On-prem.
in-house,
Yeah.
run on-prem. Yeah, full stop.
And then there's some level of security tooling and security assurance and monitoring in place.
Yeah, this is pretty vague. Can we make this more concrete?
So you would expect network isolation. You would expect enterprise identity management. You would expect log management and log monitoring.
All right. Okay. Yeah, we have some. I mean, we have the own IDP. We already have this. Okay, but these are more what we mentioned on the top are more different systems you would expect, and network.
Those
isolation.
personas would manage them. Like there would be an enterprise database. So no one is spinning up their own copy of MariaDB outside of the managed DBAs. So we would expect there's some available protected network internal services. Because if not,
okay, all systems run on premise and are governed by a, I don't know, corporate security
function team.
Yeah, program.
Yeah, that's fine. Yeah, that's fair. And because that eliminates
corporate security program.
That eliminates a lot of other attack potentials.
Yes, but I mean, for me, the main, the threats are really coming in through malicious
software
components, right?
Yes.
And so that is the main, if not the only, entry point of attackers at this point in place.
Yeah,
or at this point in time.
And if we state in our assumptions that all these internal things are not part of our scope of concern, that lets us focus on the third-party components and potential malfeasance there.
I'm a database guy, and what interested in database security, and recently zero trust security. It sounds like to be able to have a zero trust, they are have to take into account of hardware/firmware security. For example, if have a device that's authenticated, whether it's a laptop or even an IoT device, after authentication, even if the token, like even if you use PCS Spire, the security token is still active, that firmware could reset and become a malicious infected endpoint. So I guess are those in scope too?
It sounds like for right now, Victor, I don't think so, but Heinrich, feel free to disagree.
So this is basically malicious third-party firmware, right?
Yeah.
Well, this is a whole different distribution platform as well, right? So the distribution platform that we put here are really just kind of downloads. Well, to some extent, some firmware is also downloaded in that way, right? So
the firmware, I think, it's also follow the same development lifecycle, except it's a firmware.
Well, and then I think we're focused in on specifically like application software. It's a library, it's a binary, it's some other component we're ingesting to make this enterprise. So we're making on a customer sales platform. So we sell something, we sell widgets, and this development team is making this web cloud platform, and they're downloading OpenSSL or some open source database, and those are the components I believe that's in scope. We're not necessarily worried about the fact that I'm a bad developer and I want to embezzle a penny off of any transaction. We're not talking about like insider threat. We're not worried about like the nation state spy side channel kind of things. We're just focused on somebody tampers with the open source software and we ingest it into this protected kind of walled garden.
Oh,
right?
okay. Got it. Yeah.
That would also be my view, but I find it super interesting to see what we discuss and will discuss applies to firmware as well or not, and what is different. So I would exclude it for the beginning, but it would be nice to kind of keep in the back of the head and work out differences along the way.
Yeah, it's a whole other set of problems I get to deal with every day.
So focus on application level components, excluding or kind of
Firmware, malicious hardware, that type of stuff.
Yeah, firmware, hardware for the time. All right. And maybe the last asset that we came up with is, as soon as you mirrored or downloaded third-party code onto any of the internal systems, they also become kind of an asset, because what you have downloaded and what you will consume throughout the development process must not be tampered with by maybe other components. So a typical scenario could be, for example, you have an in-house build system, then you have a local cache where you store all those Maven components, NPM components or so, and you could have one which is tampering with another one. And so this is also becoming an asset as soon as you kind of mirrored it locally.
So would we, what would you consider a, let me give you a couple scenarios. A developer downloads an updated upstream library and there's a regression. There's no API or ABI compatibility and it breaks the application, and so your availability is down. How would you consider that in this scenario? It's a mistake rather than an attack. Lack of testing.
I mean, it depends on whether there's intent. And so indeed, technically, there may be no difference between a vulnerability accidentally introduced in an open source component and a vulnerability introduced on purpose. And so here the intent lets you distinguish it, and then it's the only difference. I think this should be so intentionally included vulnerabilities should be in the scope. I find this, if I were an attacker, I would find this a very promising attack vector.
And then what about infrastructure misconfiguration? Somebody misconfigures something and gives broader access than they intended. How would you consider that as part of the attack here?
So for the systems operated and running inside the organization,
So,
I think
so
this
maybe
is also this is I think this is relevant.
Okay.
Because if you download malicious open source packages, they can very well look around, sneak around, and misuse and exploit any misconfigured or vulnerable internal system. So even if we exclude insider threats in the beginning, it is still, I would say, it is still in scope.
Okay.
So which is nice, because with this we cover a lot of things that also matter for the insider threats. So in scope is as well. misconfigured and vulnerable systems. Yeah. Welcome to curly brackets. All right. Anything else? I feel this whole discussion of the architecture is super important because you were not involved in drawing it up. And I'm not sure whether you ever had. Yeah, you didn't really have the time to look much into it, right?
No, I love it. I worked at a very large bank here in the States for 7 years. So I was responsible for the web security infrastructure and then the Linux Unix server infrastructure. So I'm very familiar with this type of exercise. I love it. This is great.
Good.
I found this on the web.
Siri.
Right. And I was already happy we have yet another participant, but no, just Siri.
Just Siri. Telling me about the weather.
Right. Good. Anything else for the, let's say, initial assumptions, scope, assets?
I'd like to, did we do this every week or every other week? I don't recall.
I would like to do this in order to get some,
We did it every week.
to make some progress on this. I would be happy to have this once a week because I feel with a 2-week cycle, it would be again taking us 10 minutes to get into it.
So I'll take the action item. I will re-review the taxonomy document and then look at the large enterprise diagram here. And I'll come back with a couple more questions about scope. And I think maybe next time we'll have Abdullah and Jonathan that'll be able to, that helped build it. So I think that we'll have a good informed conversation.
I could also walk you again quickly through the taxonomy in order to explain how we build it and why we build it that way. I'm not sure you were reading yourself through the document in the past, and maybe you have used the UI. But so let me just drag this over. I'm not sure whether you see still now this tree.
I haven't.
Or do you?
I see it. I see it now. Yes, it's on your screen.
All right. Okay, so this is basically a copy of the same visualization that we did back then at SAP. And so the idea is basically with this attack tree, we wanted to basically show all the different attack vectors at the disposal of attackers in order to share and distribute malicious code and have it executed on basically at downstream consumers systems. And so the high level goal of this attack tree is to conduct an open source supply chain attack. You have here for every node of the attack tree an explanation. And basically the 3 different sub goals in order to reach this high level goal were to, in the middle here, we have all those name confusion attacks where you have typo squatting, brand checking, combo squatting and the like, right? At the bottom, we have where you subvert an existing package with all its infrastructure. So an existing package has the source code management system, a build system, and it is distributing its components through in one way or in another. And at the very top, you have this develop. Let me just increase the size a little bit. I guess you have troubles reading this well. And on the top,
old,
you
man.
have this.
My eyes are bad.
That's why I had problems reading it myself. So that's why. And on the top, you have this third attack sub goal, which is to basically create and advertise a malicious package from scratch, right? the difference why we came up with this split is basically it is they come with different degrees of attackers interfering with existing project resources. What do I mean with this? If an attacker is wanting to infect, for example, React, he would need to interfere either with its source code repository, with its build system, or with the package repository where React components are shared, right? So he really need to interact with those existing resources, which is different from the other nodes, because for name confusion attacks, there are no such resources. You just create a new component with a name that is not existing. There's no, and you just deploy it on NPM or PyPI, God knows where, and there's no real kind of, yeah, you don't attack any existing resources other than maybe the user base that used the legitimate package in the past. And then on the very top, this is again the least degree of interference with existing project resources, where you just develop something for maybe a couple of months or years before to create a user base, and then use this for spreading malicious codes at a later point in time. So these are the first child nodes on the child nodes on the first level. And then it is spreading out mostly here at the bottom. And I think this is where also, yeah, no, full stop, there was, forget about this. And so here, when it comes to subverting a legitimate package, attackers can either look and inject something into the source code repository, maybe using hypocrite merge requests, become a maintainer, or contribute as maintainer, maybe by reusing leaked credentials, or by using kind of hijacking accounts in other ways, or by exploiting vulnerabilities in the versioning control systems there, and so forth. Same thing here on the attacking during the build. You could, for shared build systems, run a malicious build in order to compromise shared resources, coming back to what you mentioned earlier, Crop. And then you could also, if you're a maintainer, you can tamper as a maintainer, and again, you can take over legitimate accounts, or you can become a maintainer, or you can exploit vulnerabilities in Jenkins, and you probably, and there are, and so forth.
I love the
and
tool.
Then again,
this is a very nice, I like what you've done, converting the taxonomy to the tool. It's very nice.
Yeah, we back then when we created this with Pier Giorgio and I, we thought this is the only way of making this huge taxonomy consumable, because otherwise you may, if you read through the paper, it's nice to have it, but then it's not really usable. Right, and on the top, at the bottom here, the third one is kind of injecting it in the distribution infrastructure, and that is including again vulnerabilities in NPM and PyPI, and there are every now and then, but also CDNs or dangling references, for example. Kind of, you have expired domains, you can re-register them, these kind of things. Or you mask legitimate packages. Here you have the basically also the dependency confusion, which is the fourth bullet here, and all these things. So this is something that happens in the distribution process or consumption process. So the idea is, now taking a step back, we go through this taxonomy and look at what can we do as an enterprise development organization to protect us against all those different attack vectors.
Mm-hmm. I love that. Very well done. I'm looking forward to participating in this. It's going to be fun.
I hope so.
I know it will.
All right. Good. All right. Good. Back to the architecture. I'm not sure whether maybe we spent a few minutes on agreeing how do we want to describe and model those threads, or do you prefer that I look something up and take it from some template?
I wouldn't mind having just the conversation. Let's focus in on, one or two boxes and talk about what could happen there, and
All right.
talk through, and then compare to what we see in the taxonomy. I think that would be useful for me, kind of brushing the cobwebs off.
Okay, so where do we start? On the very left-hand side at the developer workstation, maybe, which is probably the wildest west of all the wild west discussion infrastructure.
I guess for today we could start there. I think we'll probably spend a lot of. I think there'll be a target-rich environment for us to have discussions.
All right, and so
well, basically, I think at your workstation is all your compromised maintainer attacks. Whether they steal a credential, they're bribed, it's an insider threat. That's all kind of in that area, right?
Well, for me, it's more. I mean, one problem I could imagine is that you have, even if for bigger corporations, by now they all have, I would say, some governance on which components are selected, what are the what kind of quality criteria have to be met in order to have a component part of the application developed and shipped by this organization. And this is all nice and required, but the thing, one big problem I see is that this is just the components part of the applications. This is not what, and what the developer is downloading is a lot more. You have all these IDEs, IDE plugins, and even though maybe, he will of course also download the components to develop locally what will be shipped by this organization, but on top of that, maybe all kind of other dependencies just for trying something out, for developing his hobby projects that he's also developing on his workstation. And so that's why I basically included this top arrow, right?
Yes.
You have, because all those components ending up on the developer workstation, they do not go through such review processes, internal mirrors, or, this is just stuff that the people download directly. That is, I think, one of the big problems. Yeah.
Well, and especially with all that experimentation by the developer, you're probably going to have many bleeding edge, untested, unverified components if you're testing out something new, if you're experimenting, and if also you're doing your hobby project as well.
Exactly. Yeah. And what I find, for example, maybe a good example, even even for a component that that is part of the application that is mirrored internally, in order to consume the component from the mirror, you probably need to configure your local package manager, right? So if you use Maven, you will need to instruct Maven to use that mirror, which is managing all the stuff for you. But I'm not sure that all the developers configure this. Maybe it is configured on the build system, but the developers on their local machines still download the stuff directly from the internet, even if it is components that are part of the application, for example.
So a high degree of opportunity for misconfiguration for that pointer of source.
Right. So now the problem is, on such high level, we all agree on a bunch of problems, and we can. And I think the trick is to write this down in a structured way, I guess, to the.
Well, like you have the taxonomy, it's very logical and orderly. So we'll have to kind of echo something like that as we're describing our kind of problem statements.
I just at the bottom of the diagram, under deploy is GitOps. Is part of the terminology. Sorry about the background. GitOps, such as what is called GIT ops. I'll put it in the chat.
Right. So you're going to ask in the chat?
Yeah,
I guess.
GitOps.
You mean so? So this is related to operating your source code management system?
Deployment.
All right. So you basically have all your deployment configuration in the source code management system, right? And it gets, yeah.
I think that would be another highly sought after target.
So is the question whether this is in scope or not? I would say yes.
What was your question, Victor?
Sorry, there's somebody mowing the wrong here.
Oh.
Yeah, should it be? Yeah, it's just not mentioned at the bottom of the diagram in the deployment. I just wonder, yeah, is it in scope or not?
Yeah, but wouldn't it? So how would the data flow look like? Wouldn't it also go through the build system somehow?
I would hope so. Sorry.
I'll post more information in the chat.
All right. All right. Good. Okay, so maybe do we want to try to highlight a couple of, note down some high-level threats related to developer workstations?
So like what you just described, could we genericize that, Henrik, as developer IDE misconfiguration of sources? So you have the authorized source of trust in that private repo, but they are experimenting, so they may draw from the wrong source potentially.
Okay, so this is basically misconfigured package managers. Do not download from trusted sources, but directly from the internet. Something like this?
Yes.
Yeah, but I guess this, in the first place, this holds true for, again, for example, Maven Java components, right? I'm not sure whether such a thing is even existing for IDE plugins. And just recently, I heard of a couple of malicious Visual Studio Code plugins. That is not something that I'm not even sure that, yeah, whether this is kind of governed and regulated, and whether there are some policies around what IDE plugins can or cannot be installed by developers. Some organizations may have this, others probably don't.
Yeah, and I think the same probably holds true to like small like micro code snippets. I did a small script I have a small plugin, and I agree. It's probably very ponderous to go through your enterprise software approval process for a small snap-in for your IDE.
Yes. But I guess, no, yeah. And then it's up to every organization deciding whether it can or cannot take the risk of avoiding to go through this time-consuming approval process, and which puts a lot of load on those teams working on the approval process. Those poor guys have, I mean, in companies like SAP and Microsoft and Apple and all those big, I don't want to imagine the number of components they would need to green list and blacklist.
And it's also going to
Right.
add a lot of latency if your developer has a deadline. And again, they want to try to experiment to develop a new feature, and they want to play around. That's going to just kill their timeline, their velocity.
Yeah. All right. Let us try to write this down. So we had this first one, kind of misconfigured package managers. The other one was basically a lack of bypassing non-existing approval processes or bypassing existing approval processes for IDEs, IDE plugins, and other development tools, right?
Yes.
I
have to drop because I need to go do a presentation for my real job.
Oh, well, then that is high prio. Then thank you for joining. There was a very nice conversation. Hope to see you next week. If you can change the schedule, or maybe it is already on a weekly basis. I didn't look this up.
The calendar is on a weekly basis, and I will be here next week.
All right, great.
All right. Cheers. Thank you for your time.
All the best for your presentation. Bye-bye. Hi, Victor. So you're still here, right?
Yeah, I'm still here.
Not sure whether we will be thrown out of the Zoom in a second or not. Okay, so basically, what you want to clarify is that GitOps in scope or not, meaning, and correct me if I'm saying something wrong, configuration settings for the production environment that are managed in the source code repository and then go from there to the production environment, right?
Yeah.
So it's not really part of the code itself, not a component, but
I posted
for me,
the information, the links to that, those two products. That's yeah. So I'm also new to a lot of this since I'm a database guy for a long time. Yeah, but this information is very interesting because for newcomers to security, where to start? Where does security threat come from? There's a big question mark. So having diagrams definitely is very helpful.
I just try to. I will read through the through the documents you shared. For me, it seems to be part of the proprietary let's say code in a wider sense, including configuration, deployment configuration, and so that is very well in scope for me. I just wonder whether we need to change the. I just wonder whether we need to change the diagram to reflect another flow of that information in the diagram.
Yeah, I think it maintains not only the actual code itself, but also state of the actual implementation instances, the configurations basically.
Okay, so this would also be
yeah, it's probably just part of that the bottom box, the QA to staging to production promotion, part of that box.
Oh, okay. So basically, let's say any malicious component running in the internal infrastructure because it was downloaded could tamper with basically the configuration of production services.
Yeah.
Is that what you mean?
Yes. Yeah.
So kind of you see at the bottom there is this configure, promote, and monitor arrow flowing in from the developer workstation, where basically the developer would use his browser in order to configure production and staging environments, and this interaction could also be exercised by a malicious component that is running on the workstation and maybe anywhere else, as long as it has access to the respective interfaces of the QA production runtime. Yeah, this is kind of, for me, this would be, I wonder whether this is impact, right? Because the impact of consuming a malicious package, running it internally, the impact could be not only to kind of change, maybe to become part of an application shipped, but also to really just change runtime configuration right away. So maybe this is covered by impact of the different threads. I will try to notify this out, this as well.
Yeah, it is. That's the difficult part, and also kind of interesting part of security is there's always a new aspect of it, and there's also interaction of the different components. So it's quite a lot of different threads.
Okay, so I've noted this down, basically kind of as a comment from you to clarify whether GitOps is in the scope or not, and maybe to consider this as impact in the sense that once you have a malicious component entering your infrastructure, it could crawl basically your production or your services and then tamper with those. Maybe change accounts or bring services down or something.
Yeah, this tool is specific to the two products that I posted there, the Argo CD and Flux. And yeah, see what those two products do is part of this picture here.
Okay, let me read through this. I don't know what the Argo CD does. Right, great. Good. Anything else you want to add?
No, it's really interesting. This is what I love about the open source community. I'm like listening to the best professor free. So thank you.
Great. Happy you liked it. Hope to see you next time around. And I wish you a nice, I don't know, evening, day, morning, wherever you are.
Yeah, I'm in Tampa, Florida.
All right. So then you have a nice afternoon, I suppose. No, evening.
You're in are you Europe?
No, sorry. It's the other way around. I'm confused. It's 10 o'clock in the morning. So then have a lovely day.
Okay. Yeah, you have a good one too. Yeah. Bye.
Yeah, I'm sitting here in Europe. So it's 4 o'clock in the afternoon.
Okay. All right. Have a good evening then. Yeah.
Thank you. Bye-bye.
Bye-bye.